Welcome to Massive Open Online course on chemical process intensification. So, today's lecture will be on strategies and domain based techniques under module 1 introduction. So, in the previous lecture we have discussed something about the basic principles of the process intensification along with some other perspective of process intensification. And we have discussed that generally for basic principles as per Garvin and Stankiewicz 2009, that the basic principles of the process intensification will be the effectiveness of the intra and intermolecular events, and based on which that any chemical engineering process intensification starts, and it will start from the molecular level that will give you some reaction mechanism, and from which you will get some products, and after that all molecules will have the same process experience based on which that the direction of the process will go, and after that basic principle of that process intensification is to maximize the synergetic effect from the partial processes of different chemical engineering processes, and then optimize the driving forces at all scales and maximize the specific surface areas based on which the intensification can be done for process chemical engineering process. And in that case you will see whenever we are getting different products after reactions, and then you need to have to separate the products and byproducts from those mixture of chemical reactions, and for that several separation processes are actually implied to separate those chemicals or compounds. Based on the process intensification principles, all those compounds are being separated by different mechanism, by different processes, by their process intensification. And in that case the effective surface area is one of the important phenomena because all the chemical processes actually directly or indirectly related to the multi-phase flow processes. So, in that case the more than one phases where taking place to take part in reactions and yield the different products. So, in that case to separate those products, so you have to have the surface area between the phases. So, in that case contact areas as well as its residence time in the reactors is main important features or main important aspects by which you can optimize the driving forces based on which that compounds are being separated from one phases to the another phase. So, in that case different other whatever that operating conditions will be governing those degree of driving forces for this mass transfer or separation processes. So, you can develop some equipment or device or develop some methods based on this criteria and optimize those process by this process principles. So, these are already been actually described in the previous lectures. Even some other that basic features, that is most important aspects, that is given by Gabriel Segovia Hernandez and Bonilla Petriosilate. So, in that case they have given that the principle of this process intensification depends on three main features. It is referred by them as a triplet feature. They have told these features as molecular process, product and process engineering. This molecular process means the reaction process in molecular level, and then by this molecular process you can get the product, and the product will be of course the mixture of different products and byproducts, that is desired products and undesired products also, even unreacted products also would be there. So, after that, to separate those products you have to separate those products or byproducts based on some principles. So, that is called process engineering. So, this process engineering is developed based on the mechanistic properties of this or physical properties of the products and byproducts, based on which how it can be separated. Now, there are different aspects of separation processes and intensification of those processes, like you know that this intensification can be done based on the physical process, based on the physical phenomena, based on the you know that equipment what are used for that particular process. So, development of some equipments, some novel devices by which you can separate these products by this process engineering method. Other phenomena like that you can develop some methods, that conventional methods can be avoided to get intensified way to separate those projects. Like sometimes you know that to separate those products and byproducts you have to mix the phases in intensified way. Now, there should not be back mixing in that particular processes of the phases. So, in that case you have to reduce that back mixing. To reduce that back mixing you have to develop some process, you have to develop some methods, you have to develop some devices, so that there will be less back mixing or higher residence time there. So, this is the thing, and based on this process engineers then you can have the final products with a certain degree of purity. So, that is called approach to manufacturer end, that will use for commercial purpose, and in that case implement of the multi-scale application of computational chemical engineering model is also important, because all those process how it has happened, how to predict those processes, what will be the yield, and based on the operating conditions what extent of product, what extent of efficiency of the process can be obtained, that can be actually simulated or mathematically interpreted by some simulation process or mathematical expression. So, that is why the implementation of this multi scale of applications of this process engineering for the process intensification, you need to do the modeling and simulation of the processes, and those things. So, of course, based on this modeling simulation purposes, this design engineering of course will be actually progressed on, because all the design of this equipment or intensified devices, that depends on the you know that physical phenomena of the process inside that. So, before going to design you have to do the experiment in laboratory scale and simulate based on that laboratory scale data and scale up to higher commercial scale. So, this is the way, that is triplet features that is given and based on which that you can intensify the process. Now, in this lecture we will discuss something more about that process intensification. It is called strategies of process intensification, and also what are the domain based process intensification techniques are available, we will actually discuss here in this lecture. Now, see in this table that if we classify these strategies of the process intensification, and we are having three strategies, like one is business, another is process, and then environment. In the business aspect, of course, the main strategies of this intensification is that you have to miniaturize the plant, that means you have to scale down the plant, that is you know that smaller size of plant will give you less consumption of energy, less consumption of cost. So, in that case you have to have the such strategies of miniaturization of the plant, and also reduction of the capital cost, whatever investment, that investment should be less based on this reduction of the capital cost by designing in such a way that the small scale equipment should be designed in such that it should be efficient and it should be given the same output as conventional processes. So, also wise distribution of the unit, that is also one business strategy, that you whatever products is coming out from the that process, that you have to distribute in well management throughout the unit and throughout the different commercial hub, so that the product should be wisely distributed and it will be well managed and optimize the prices of the output. And faster introduction of the new products to market, also you have to well advertise in the market, so that your new products whatever it is coming that in the market, not that nowadays that advertisement is the main important factor, that how you are actually selling the products, that you have lot of products, but sometimes the consumers may not come to you because they do not know what type of products and what extent of purity of your products, that is to be actually advertised in the market, so that the consumer can easily know your product based on your what is that intensified way. And then the process strategy is that anyway your strategy should be in such a way that the selectivity should be high. So, you have to develop the process where high selectivity can be achieved, and also the whatever reactions are being taken place in your process intensification way in chemical engineering or some other engineering processes, that if it is some reaction oriented, then you have to increase the reaction rate, and also after reaction and you will get the products, that you have to separate those products in a certain degree of purity. So, you have to improve the product purities, and also improving the process safety whenever you are doing some process for producing some products. So, you have to make some first hand safety for that operation. So, it is also important. Now, safety not like that conventional way, you have to take measure intensified way of safety for that process operation. And wider processing conditions also important there. You have to keep in mind that try to minimize that process condition, because lot of conditions may sometimes interact to each other and they may hinder the process output there. So, as much less as possible that process conditions to be actually optimized there. And also some processes that are coming with this less number of that process conditions by integration of the process. So, you can integrate the process, you can conjugate more than one process in a single unit, so that you can omit some, you can that avoid some unwanted process conditions what happens in a particular process. So, that is why the process integration is also one important strategy for process intensification. Then environment, this is one of the most important strategic feature of that process intensification. You have to intensify the process in such a way that your energy use should be less, your waste whatever waste is coming from your process operation, that should be reduced, and what are the solvents that you are using, that should be intensified solvents, so that waste solvent should be less. And smaller plants are one important aspects, that you have to scale down of that process to get more output, and also finally that less pollution. this is the final goal. Whatever products are coming out, that should not be hazardous in nature, that should not be making any pollution in the environment, that should not be any health problem in the society. So, in that way you have to intensify the process, so that after output whatever coming after this process intensification way, that will get less pollution in the environment. So, there are three strategies what we are actually dividing here. One is administrative processing, that is business purpose. Another is faster, safer and greener processing, that should be like process higher selectivity, how can get the higher reaction rate, how can improve the process safety, how can reduce the wider processing conditions, how can we integrate the process to consume less energy and also less precautions to be taken during the operations. And also sustainable eco-friendly processing should be there, so that the less energy can be consumed and less waste will be there in the environment, and less chemicals to be used, so that the hazardous materials will not be coming into the environment, and also as smaller as possible that you have to make these plants, and also less pollution to be created. So, these are the basic strategies of the process intensification, like business, process and environment. Now, these are the whatever strategies that we have told, that is strategies actually not entirely new in chemical engineering. In chemical engineering, all in chemical engineering process, all those strategies are actually taken care, but nowadays since populations are being increased and pollution in the environment are increased, so you have to have some explicit goal to reach the clean environment by some process intensification way. And in that case you have to consider the chemical engineering process in a some classical way, so that you can get the less polluted environment in society. Now, for that, you know that our society has to face the challenges of that modifying the traditional industrial growth to a sustainable growth, because our population is day by day increasing. To fulfill our demand and the society as well as the market, whatever it is that, so we have to face lot of challenge to fulfill our goal to supply the products as per demands. So, for that many strategical operations in different strategic sectors are taken, like water, energy, food, health, etc. In different sectors they have taken, they have actually developed different processes for the intensification of the process, so that the necessary transformations will take place consistently with the process intensification principles. So, that is why the challenges to the sustainable growth is here to actually fulfill the demand of the society in our populated domain. So, however, limited natural resources entail their efficient use, while simultaneously enhancing the quality of the life of current and future generations. We are of course bother about that we have to give the better generations, we have to give that quality of life to our future generations. So, in this respect we have to develop the process in such way that it will become an immensely important tool to achieve overall sustainability of the chemical process industry and the reduction of our energy footprint through different basic features. Now, innovation of the equipment is one of the important features based on which that you can intensify the process and you can give the better products and more products in the society. Design and process development methods that are expected to bring substantial improvements in the society. So, for the process intensification, you have to design and develop the process in such a way that you can have substantial improvements in process methodology, development of the equipment, and the sustainable growth for our society. Also, substantial improvements in chemical and any other manufacturing and processing aspects, that also very important tools, and that depends on some factors like that you have to decrease the production cost, you have to decrease the equipment size, you have to decrease the energy consumption, you have to decrease the waste generation which is coming out after process, and also improvement of the remote control, and also improving information fluxes and process flexibility. So, these are the main tools by which you can that improve in chemical and other manufacturing process aspects there. In this case or in this regard, we have to say what in this regard of green chemistry, where it is one of the important strategical movement for process intensification in chemical engineering or chemical industry, where you will see the whatever chemical processes are being carried out, that should be in a greenery way. That means less number of hazardous materials to be produced by this green process. So, green chemistry is one of the important tool by which you can develop some process, and based on which you can get the some products which will be highest purity and also less environmental pollution. So, in that case you have to use some solvent that will not be hazardous, and 100% use of solvent should be there, and whatever byproducts will be coming out, that should be that again to be converted to some other useful products in the society, so that the hazardous material as a byproducts, that should be converted to other products, and it will be useful for other uses. So, in that way you can converting these hazardous materials to other useful products. So, that is why whatever green technology that should be used, you have to consider some that efficient solvents, where the less waste of hazardous materials are coming out in the products. So, green chemistry is defined as the utilization of set of principles that reduces or eliminates the use of generation of hazardous substances in the design, manufacture and application of chemical products. So, the main aspects is to that develop the process in such way that whatever reactants, whatever materials to be used for that intensification, process intensification for this greenery way, that green chemistry should be followed. So, green chemistry, that means synthesis of the chemicals in such way that less number of hazardous materials to be produced during the synthesis process. And here you will see whatever process we are talking about for the process intensification and to get these products, and then after business, you will see there are different processes in mechanical process, physico-chemical process, even reaction processes. Those processes may simultaneously occurs or integrated way, that may happen or individually may happen. Some mechanical processes that may not actually integrated with the reactions there. Some processes totally that mechanical means, here suppose you want to reduce the size of catalyst particles there to get the more surface area, so that the reactions will be intensified. Or some processes that like separation, physical separation processes, in that case particle size is very important. Some fluidization processes in chemical engineering processes, you will see they are the size of the particles matters. So, in that case mechanical processes where you will see the size reduction is needed. So, in that case you have to intensify that size reducing process. Some other mechanical process for physical separations by membrane separation, you have to develop some membrane, that different types of membranes, ultra, even nano, even that mesoscale level, even some different types of materials, ceramic membranes, polymeric membranes, there are different membranes. So, those are mechanical way to separate that different products and byproducts. Some physicochemical process for absorption, there you will see some suppose separation of sulfur dioxide or nitrogen dioxide or carbon dioxide in a liquid. So, in that case main process is that it depends on the physical properties of the system, like what type of solvents, what are the properties of the solvents that you are using for absorption of carbon dioxide from the atmosphere, or NOx, separation of NOx in amine solution or some other solvents. So, you have to develop the solvents, you have to develop the that interfacial area to separate those gases into a liquid. So, these are called physicochemical processes. Even reactive processes like reactive distillation, extraction, reactive extraction, even reactions processes to synthesis the different products and byproducts from a natural sources, that is reaction. So, after getting different products by this mechanical, physicochemical or reaction processes, you will get different products. So, those products to be separated by different processes. Now separation processes, or it is called upgradation processes, you have to separate different products and byproducts in different uses. And based on hydrodynamics, heat and mass transfer, that separation or upgradation to be actually depending on, because whatever reactions or whatever separation processes are being carried out in a particular reactor or in a column or in a devices, how this devices is being operated, there are different variables that actually governs these processes, like suppose separation efficiency or yield of the separations, or suppose mass transfer, basically main terms is mass transfer, heat transfer. That mass transfer and heat transfer, that depends on the operating conditions there, and main parameters based on which that mass transfer or heat transfer depends on, it is called mass transfer coefficient or heat transfer coefficient. Even these other parameters in hydrodynamics, like if you are working with, or your operation of the process is with suppose different phases, like gas and liquid, gas, liquid, solid in a particular unit, like fluidization operation, they are gas solid fluidization, like combustion of coal to produce different type of gaseous products. Even Fischer-Tropsch synthesis from the natural gases, how this natural gases or that synthesis gases to be converted into different gasoline, even other different LPG or other different gaseous products, even some other petroleum products that are being produced. So, in that case the process that is performance, that depends on different operating variables. That operating variables are like this, that some are called dynamic variables. Dynamic variables are called that flow rate, even velocity of the fluid inside the reactor, even that some hold up of the phases inside the reactor. Even some geometric variables, you can intensify the process based on the that operating variables, like it is called geometric variables, like you can change the diameter of the column, you can change the length of the column, you can reduce the size of the catalyst what are being used actually for particular chemical reactions as a catalyst. And you can change the what is that distributor through which that gas or liquid is being distributed or spraying to get the more interfacial area of the phases or interfaces through which mass transfer happens or heat transfer happens. So, this geometrical variables also governs this process performance there. Other like physical properties also important variables, like if you are using different types of chemicals, different solvents, different reactants, you will have different physical properties of those reactants or liquids or fluids that you are using, like physical properties like density, viscosity, surface tension, all those will vary, and all those properties will actually change the process performance in your particular operation. So, this heat and mass transfer process are involved in separation and upgradation process, and this heat and mass transfer, that will actually depending on the hydrodynamics, that means how fluids are being actually behaving inside the reactor, whether it will be circulating well or it will be homogenization, or whether it will be heterogeneously actually mixing inside the bed, that depends on the process output. So, you can intensify that that process based on this hydrodynamics, heat and mass transfer phenomena. And after getting the products and byproducts based on this upgradation and process intensification, for this you have to anyway market these products for business purpose. So, you have to make a strategy for that business, how actually consumer can get those products easily, and also aware of those products in the market, whether it will be acceptable range of degree of purity or not, that should be actually highlighted in business strategies, and also the advertisement to be given in the market, so that your degree of purity of the products will be in a certain level. So, that is business strategy, how to actually sell the products in the market easily, and how to aware the peoples that these products will be good or not, that should be actually considered. So, these are the strategies that some process intensification is for reaction conditions, where this mechanical, physico-chemical and reactions are being actually considered, and process where that intensification is for product upgradation, their separation upgradation based on hydrodynamic, heat and mass transfer to be considered, and intensification should be based on the marketing and business strategy also. Now, according to Garvin and Stanquist 2009, they told that the process intensification strategy should be in the four way, like that the some should be spatial, that means here less the space should be used, that means here macro to micro plant should be developed, and their thermodynamic condition to be considered there, that means less energy to be consumed. So, in a particular process, suppose higher pressure drop is there, so you have to reduce that pressure drop, because higher pressure drop whenever in a particular reactor, that to distribute the fluids, more energy to be consumed for uniformly distribute of this that fluids. So, in that case energy consumption will be high. So, you have to keep in mind that how to intensify those process by less consumption of energy, and by that having less that pressure drop inside the reactor, and also as much as possible that the reaction should be that atmospheric condition, so that extra energy, extra heat should not be supplied there for that process output. So, the energy is one important point for this process intensification strategy. Also another is functional, of course different condition to be considered here, functional, whether it will be that based on flow behavior, or whether it should be based on other physical properties of the system or not, how it can be actually processed based on the physical properties, that means less viscous fluids to be used, less hazardous materials to be used, even less consumption of solvent will give you a higher output. So, you have to synthesize the solvent or materials in such a way that it will give you the higher proficiency of the product output based on these material properties. Temporal, like you have to use less time for your products for your production, because in that case if you are consuming higher time, so you may consume more energy, more that capital cost should be required. And also in a particular process, chemical engineering process, in that case for higher residence time, sometimes it may hinder the process output. So, sometimes some particular processes you need to have less residence time of the fluid. For those processes you have to design the process equipment in such way that for higher residence time, for longer time of the fluid element to be staying inside the column. Like that for getting more residence time, I told that earlier that downflow column, suppose gas is to be supplied from the top to bottom in a reactor against its buoyancy, then you can get the more residence time of the gas bubbles for mass transfer through the interface. So, in that case downflow movement of the bubbles or inverse bubbly flow is one important aspect of process intensification to get the more residence time of that bubble or fluid. And so, according to Garvin and Stenguis, that a completely intensified process is successful in realizing all these process intensification principles by making use of one or more fundamental approaches in such 4 domains. And the whole process intensification strategies in chemical processing can be based on 2 areas here: equipment development and techniques development. Whatever process that we have actually discussed, all those processes you can concise in a 2 way, like the equipment development is also one important, because whatever reactors are being developed, so reactors should be intensified way, so that your reaction mechanism should be intensified. And also techniques development, different techniques should be, conventional techniques to be avoided, because in that case higher energy is being consumed, as we know. So, you have to develop some techniques where the less consumption of energy will be there. Even greenery way, that you have to develop the synthesis process, so that you can get the less hazardous material which will be used for different products for our daily use. And new methods may require novel types of equipment which is to be developed, and vice versa. Now, equipment development, for that you have to consider some novel reactors like chemical looping combustion reactor, fission reactors, ultrasonic reactor. Based on different that process intensification techniques that you can develop, the novel reactors are there. There are several other reactors are available nowadays for the process intensification. And also intensive mixing device to be actually developed. Sometimes you have to have the homogenization of the fluid mixture in the reactor. So, you have to mix the fluid in intensified way. So, you have to develop some mixing device where gas liquid or gas liquid solid, or solid or gas to be mixed in the reactor. Like the sometimes static mixer are being used, where channel based mixer sometimes is considered for gas liquid mixer. Even in fluidization, instead of packed bed, you can mix the solid gas more intensified way, just by that circulating that gas inside the bed. So, this is called circulating fluidized bed. So, in that case you can mix that solid in homogeneous manner based on different flow patterns. So, other intensified device like corrugated static mixer, Duff and confectionery mixers These are some examples of intensified equipment or mixing device where commercially being used. Heat transfer device like that coil master heat exchanger. If you are using only a simple straight tube for heat transfer, to that heat the liquid, you have to supply another liquid or gases that is maybe cool or heated. So double 5 heat exchangers are there, shell and tube heat exchanger there, even fin tube heat exchangers are there. Now coil master heat exchanger important because you have to place that heat exchanger in a very small space. So in that case sometimes the tube should be made a the curve shape or helical shaped way. So it is called coil shaped. So you have to supply that liquid through the coil, hot water through the coil in a less space, that is number of turns, that depends on how actually intensified way that heat transfer can be done by this coil. And also fin tube heat exchanger, they are just increasing the surface area to improve the heat transfer phenomena. This type of heat exchanger are being developed. And also separated surface heat exchanger, also that channel based heat transfer equipments are being developed nowadays. Micro channel based, they are n number of micro channels are being, through which that liquids will be supplied, or some solvents, or that refrigerant to be supplied, so that the other liquids which are to be cooled down can be easily done. So these are called micro channel based heat exchanger equipment. So as a process intensification for heat transfer, the heat transfer device are being developed based on that surface area. Mass transfer devices also are being developed based on the surface area. Even cavitation reactor, where you will see that some gas bubbles to be produced, even by sono, or you can say that ultrasonic way, that bubbles will be produced, so that it will be its size will be more finer, that is called micro bubble. Even nowadays nano bubbles are also being produced for getting that is more mass transfer, separation of the some particles. Micro bubbles are being used in mineral industries for separation of fine particles from the solution. Even these micro bubbles are being used for arsenic removal in advanced oxidation process like ozonation process. Even micro bubbles are being used for medical industry, for gene delivery, drug delivery, all those purposes these micro bubbles and nano bubbles are being used. So these cavitation reactors are being developed in such way that where micron sized bubbles can be developed by this ultrasonic mechanism. Monolithic reactor is also one type of reactor where some materials are being synthesized there, and in that case nanomaterials to be developed, and based on that nanomaterial properties, that intensification of the process are being done. And spinning disk reactor also nowadays are coming, that separation as well as reaction both happens simultaneously in integrated way. So in this case spinning disk reactor is also one important intensified equipment for mass transfer. So the process intensification are being actually done in different way. So equipment development is one of the important aspects for that. Main strategy for this techniques development is to develop the new and hybrid separation techniques, integration of the reaction and separation, heat exchange or phase transition, even some methods to be developed where interfacial phenomena works, and also techniques that should be developed where alternative energy sources are to be used, like light, ultrasound, etc., or you can say that some other magnetic field where this alternative energy is being used to intensify the process. New process control method of course to be developed for this process intensification. So we can even classify these strategies of this chemical engineering process like that integration of the operations, functions and phenomena are three components by which you can intensify the process by integrating the different processes. Based on these principles, the process intensification is achieved through adding and enhancing a phenomena within a function and or operation for improved equipment design in order to maximize the driving force or to overcome limitations that occurs in the corresponding conventional processes. And targeted enhancement of a phenomenon of a given operation that also influences the process intensification to get through improved use of respective phenomena or functions to overcome limitations that occurring in a given conventional operation. Some domain based process intensification techniques are also there in chemical engineering process. Those are very important, like absorption, adsorption, stripping, distillation, heat transfer, liquid extraction, crystallization, reactions, centrifugal fields and dedusting or demisting. Some other operations like fluidization, even bubbling phenomena. So, these are the techniques based on which you can intensify the process. And for that some focus to be of course to be considered on that structure and the internal geometry, like this that high to get the high mass and heat transfer rates, maximum specific surface area and minimum energy expenses. To have that you have to drive that process in such a way that you can get the high mass transfer and heat transfer rates there. And also this happens in generally some common equipments whatever available in the market, like compact heat exchangers, plate and spiral, multi-stream, mini channel, even shell and tube heat exchanger, where a static mixer sometimes is being used for this mass transfer, and also structured packing material also are being used for getting more contact between the phases, so that heat and mass transfer to be more. Even that some energy and energy forms and mechanism of those are considered for that heat and mass transfer there, like excitation of the targeted molecules sometimes is being done for reactions before going to its main processes. And also new operational windows, selective local energy supplies also to be considered for that intensified way to get the process intensification, like that microwave reactors, sonochemical reactors, there are some magnetic field assisted reactors are there, spinning disk reactors are there. There that some reactors or separators are to be developed based on this that new operational window and selective local entropy supply or energy supply there. So, their energy and the form of energy and based on which that how mass transfer and heat transfer will be happened. So, based on which that process intensification can be done. Even some other important operations like supercritical separations, fluid extraction, even fluid that solvent extraction, ultrasound enhanced crystallization, even hydrodynamic cavitation reactions there, where this process intensification is being done based on this energy and transfer mechanism of that. Even some other electric field assisted extraction process, dispersion, rotor stator devices, mixers, microwave and radio frequency drying microwave, even heating and drying, rotating pack bed, centrifugal contractor and extractor impinging stream reactors are also being developed based on this energy and transfer mechanism. And some other mechanism like that drive and intensives like synergetic effect, overcome equilibrium limitations, compact equipment, increase of overall efficiency there, like membrane reactors or crystallization, membrane extraction, even distillation per evaporation systems are some common examples of intensified process in chemical engineering process. Dividing wall column technology is also important. Heat integrated distillation column are being used in the present days. Reactive distillations where conventional only one simple operation in distillation are not being done nowadays. So, integrated way like reaction as well as distillation parallelly will happen in a single reactor. So, it is called reactive distillation. Reactive absorption and extraction both will be simultaneously occurs in a particular reactor. Even membrane assisted reactive distillation, sometimes after reactions you have to separate those products, so you have to use some membrane. So membrane assisted reactive distillation is a conjugated unit, or you can say integrated unit, where this process intensification is being done. Even some other process like you know that gas solid trickle flow reactors in downflow systems, they are mostly petroleum industry, they are using this gas solid trickle bed reactors for catalytic cracking and other several petroleum products to obtain in a particular this trickle bed reactor. Controlled energy input is also one important you know that incentive strategies for you know chemical engineering processes like cyclic distillation, millisecond reactors. They are even pulsing operation of the multi-phase reactors are nowadays happened, because to get the homogenization of the phases, pulsing operation gives the proficient operation in that particular packed operations. Reverse flow reactors, oscillatory bubble reactors are being used for intensified mixing in the fluid in a particular reactor to get the better yield in the chemical engineering processes. So, there are several process intensification with alternative sources and forms of energy that are being here given. So, high gravity field, electric field, electromagnetic field, microwave, even electromagnetic field light, acoustic field, ultrasound, supersonic shock waves. So, to use those energy incentive you know that process, the chemical engineering process are going ahead based on this strategy, that you have to develop some process and to get the you know that magnified way of intensification, like you know that reaction time, you know equipment size, liquid side mass transfer, gas side mass transfer, interfacial area, heat transfer, reaction time, distillation time, you have to magnify this process output there. So, different strategies that we have considered here in this lecture. I think we have now considered that what type of strategies to be considered for the process intensification. It will be helpful for your you know the process design. Thank you for this lecture. I would suggest you to for further reading of these books for further information on this process strategies for process intensification. Thank you.